14.7 trigonomic ratios. Today I need you to look at special triangles, right triangles. We talked about similar triangles and how they have proportions that are the same with their lengths of their sides. We talked about ratios yesterday in 14.7, special right triangles that have 45 degree angle or 30-60. Now we're just talking about special triangles that are just right triangles again, but the trigonometric ratios that they have. Before we can start talking about that, though, we have to look at a right triangle and make sure we know what we're talking about with the sides of a right triangle. If you look at this right triangle here, you should know already that this means 90 degrees. That's what we use to write 90 degrees instead of the number 90 degrees. And in relationship to the 90 degrees, there is a long side of a triangle always. There should be the one longest side, and you should know the name of that. The name of that is the hypotenuse. And in this one, it would be this line right here. These are called the legs, and this would be the hypotenuse. The hypotenuse is the longest side. Now on this one, you can tell visually that it's the longest side, but you won't always be able to tell. Sometimes you look at it and go, which side is it? So in order to be foolproof, you have to think of it this way. If you can find the 90 degree angle or the right angle, you would go directly across from that right angle. That would be your hypotenuse. So in this situation, this one would be longer than this one. So this would be your hypotenuse. And this again, if you go directly across, that is the hypotenuse. This one again, you can see visually. This other one is a little less easy. So once you have the hypotenuse, then I need you to think about the legs. If we were, let's say, just to highlight just this angle right here, okay, and we want trigonometric ratios according to this angle, okay? We always pick an angle. It's always an angle that we're looking at. So if we were to say, according to this angle, which is the hypotenuse? Well, you know that no matter what, it's always this. But with the legs, the leg that is over here, that's across from that angle we're talking about, is called the opposite, because it is opposite your angle, okay, across from it. It's the only one that this is right next to it, this is right next to it, this one is opposite. So that one is called the opposite side. Now, this leg here then is called the adjacent. The adjacent leg. So you have the opposite leg and the adjacent leg. But don't let that confuse you, because what can happen is we could choose a different angle, and then the opposite and adjacent changes. What if we were talking about this angle here, and we were referring to the pink angle? Now the hypotenuse, always the same, right? Still is that longest leg, or longest side, I should say, still is this. But if we're looking at this angle, now this is opposite. So for the pink angle, this would be opposite, whereas this leg would be adjacent. And adjacent simply means next to, right? Adjacent to it. Here's the angle. This is the one that's adjacent. This is the hypotenuse. It's also adjacent, but it's the hypotenuse. That one stays the same. So the two legs depends on which angle you're referring to. So let's do one more here, and then we'll do some practices. So here's the right angle. You should know directly across from the right angle would be your hypotenuse, which would be here. Okay, hypotenuse. And then let's say we're talking about this angle here. Then this would be opposite leg, and this would be adjacent. And that will come into play as I explain the trig ratios in just a moment. let's get right to that. Okay. When you study the ratios between the sides of right triangles, those are called trigonometric ratios or trig ratios. There are three that we're going to talk about today, and you've probably heard of them before. There's sine, cosine, and tangent. Those are the three basic ones we're going to work on. It's just a little introduction of it before next year when you get it into a little more depth. If you look at the sine, cosine, and tangent of a certain angle, you will have to know what is opposite, what is adjacent, and what's the hypotenuse. So let's first look at that. We're looking at the sine of angle A, the cosine of angle A, and the tangent of angle A. And I'll explain what these are in just a moment. So angle A is what we're focusing on. So let's label which is opposite and which is adjacent. Well, we know here's the right angle, so this is going to be the hypotenuse. And this one, again, is fairly easy to see that this is the longest one. But then if we're looking at angle A, the opposite would be this side, and the adjacent would be this side right next to it. Okay? Now, the ratios are like this. This is how we remember it. Sine is opposite over hypotenuse. Okay? So when you are looking at the ratios of sine, you are always looking at opposite over the hypotenuse. That ratio. So here we go. Opposite would be A over hypotenuse C. So in this situation, A over C would be your ratio of sine of angle A. Now again, angle B is going to be different, right? We're talking just about angle A. Cosine, when you look at the cosine, you're going to look at adjacent over hypotenuse. Okay, so you got opposite over hypotenuse and then adjacent over hypotenuse. Can you guess what tangent of angle A is going to be? Some of you probably can guess. What's the other option? Opposite over adjacent. Okay? Now, there's kind of a silly way to remember this, and you're going to get a helpful handout, or you should have gotten a helpful handout already from me from last week. But it's simply saying over and over again, so, ka, toa, so, ka, toa. Those are these ratios, and I'll show you how. So, trig ratio, so, ka, toa. What does that mean? S stands for sine. The ratio is opposite over hypotenuse. So you get SOH, SOH. So, ka is cosine. And you can guess what A and H are. The ratio is adjacent over hypotenuse. Ka. Toa, tangent, which is opposite over adjacent, is your ratio. Okay, these are different ways to write it out. We won't get into this year, but next year we may use this more when we use a fancier calculator too. Right now we want to just focus on these ratios, and for you to keep saying so, ka, toa, so, ka, toa. So, ka, toa is going to help you to remember which name goes with which ratio. Okay, down here it kind of explains that too. And so you can use this as you do the homework. Use this as your helpful handout throughout this whole thing. So sine is so, opposite over hypotenuse. Ka, cosine, ka, adjacent over hypotenuse. And toa, tangent, tan A, tangent is opposite over adjacent. Okay, so if we're looking at this, they're asking for sine A, cosine A, tangent A. You always have to first look at what angle are we talking about. This is asking for the sine of A. So the one we're looking at is here. Okay, that makes a difference which is which here. Okay, this is opposite, this is adjacent. So you would have to be careful because that you think, well, that's obvious, but when you do your homework, it's easy to make a mistake on that and do the wrong side because you're looking at the wrong angle, and it just gets confusing. Hypotenuse never change. No matter which angle you use, that's the hypotenuse. So let's apply this a little bit. Let's look at this one. We have a right triangle. We have, let's label it. If this is the right angle, we know that this is our hypotenuse. This wants the sine of A, cosine of A, and tangent of A. So let's make sure we focus on this angle. And then we can even write it on here right away. The opposite is here, and the adjacent is here. Then we won't get mixed up right away either. So let's practice. So S-O-H, Ka, C-A-H, Toa, T-O-A. That should help you. If you just write this out right away, that should help you not make a mistake. So then we go sine of A, opposite over hypotenuse. Opposite over hypotenuse. 6 over 10. Or we could say 3 over 5. We divide both by 2. Okay? Let's try another one. Cosine, adjacent over hypotenuse, which would be, if we divide both by 2, that would be its ratio. Tangent, Toa, opposite, opposite over adjacent. And simplify, divide both by 2. And there you have your trig ratios for this particular right angle. Simple as that. All right, let's try a few more, and then I'll let you send your homework. Another right triangle. Remember, this is only with right triangles. Okay, this is not with any triangle. This is only with right triangles. Now, this one says sine of 60 because we have a 60-degree angle here and a 30 here. So they want you to focus on this 60-degree angle. So highlight that so you do focus on it. And then let's see what sides are going to be what. The one across from the right is always our hypotenuse and always our longest side. Here's our angle, so this will be adjacent, and this will be opposite. Writing those down just help you not make the mistakes that are easily made. Okay, let's try to write this out first. S. So, Ka, Toa. All right. This is what we're working with. We need opposite over hypotenuse. Opposite over hypotenuse. Okay. Now, sometimes they're going to ask in your book to give you, with this ratio, they're going to ask you to use the calculator and round it. Round it to the nearest thousandth or hundredth, and then do appropriately. Round it to whatever they ask for. So on this one, if we were to do this, we would just take 1.732 and divide that by 2, and let's say they want it to the nearest hundredths. So then we would just say 0.87, and that's all you would do. I think the book might ask for thousandths usually, whatever they ask for. So let's do cosine of adjacent over hypotenuse. Okay, and if they want a decimal form there, obviously it's going to be 0.5. And then tangent, opposite over adjacent, which is just going to equal 1.732 if it's thousandths, 73 if it's hundredths. Okay, so that's pretty straightforward and simple. Key thing is to make sure you use the right angle. I don't think we need to do, I think we'll do these on the bottom here and skip that top. I think you've got it. I think you'll do just fine. Let's do a couple of these and then we'll let you loose. So sine. So, and that would be opposite. Well, let's see. What are we working with? D. Okay, and I'm going to do this to the nearest thousandths. That's what your book will ask too, I think. And we'll just do a couple of these so you can see how to do them. So here's your angle. This would be opposite. And this would be adjacent. Okay, so opposite over hypotenuse, which is always opposite the right angle. Okay, didn't draw it there, so that would be confusing, but that's your right angle. So opposite, 1 over 2.236. And then I would just use your calculator and divide. And I think your directions in your book also says use a calculator. So we get 0.447222. So we round it. 0.447 would be the thousandths. 2 means I stay at 7. Okay, cosine of D. Cosine ka. So I need A over H, adjacent over H, hypotenuse. And then we find that ratio. 2 divided by 2.236 equals 0.894. 4 means we stay there. And then tangent. SOHCAHTOA. Opposite over adjacent. And that's just going to be 0.5. And that's it. So email me if you get stuck, but that should be a good start for you. I think you'll find that that's fairly easy after you've understood it. Good luck.